Okay guys, so here we're going to start another video lesson where today we're going to talk about the types of chemical reactions, and I'm going to guide you through 5 types of reactions. Okay, the first one we're going to look at is what's called a synthesis reaction. Okay, so a synthesis reaction. RXN is my abbreviation for reaction. Okay, and this kind of reaction is the reaction that you have when you have um, 2 or more substances that are making one product. Okay, so 2 or more substances yielding only one product. That's actually a really important key, that one product. Whoops, didn't mean to do that. Let's highlight. Let's try that again. One product. Okay, so let's look at an example of what a synthesis reaction might look like. Um, you could have something like, say, calcium oxide plus water would give you calcium hydroxide. Sorry guys, the cleaning people actually came in. That's how late I am here for you. Ha ha ha. Okay, let's go back to the lesson. So here we have again just 2 products and then making one, excuse me, 2 reactants rather, making one product. Okay, so that's the first kind of reaction, which is a synthesis reaction. The next type of reaction that I'm going to show you is usually the favorites of my students. It's what's called a combustion reaction. And as you would expect, a combustion reaction is when you have fire. Right? Really what it means is you are adding oxygen gas and you are producing carbon dioxide plus water. Those are always your products. Carbon dioxide and water, when you're looking at hydrocarbons. Sometimes you'll just have another product, depending on what you're adding. But the biggest key here with combustion reactions is this adding of oxygen gas. So let's look at the most common combustion reaction is the combustion of methane gas, right, which is a hydrocarbon, which means it's just hydrogen and carbon, we see. And we're going to add O2, add oxygen gas, and of course we're going to produce carbon dioxide gas plus water gas. And hopefully you're looking at this and going, wait, Ms. B, it's not quite right, you need to balance it, and what would you do? Okay, well, you would add a 2 here, and then you would add a 2 here, and now we're good, we're balanced. But this is the combustion reaction. Again, the key point here is you're adding oxygen gas, and you're producing carbon dioxide and water. Okay. So that's that reaction there. So far we've been looking at 2 types of reactions, a combustion reaction and a synthesis reaction. And I actually want to show you another type of combustion reaction. So here we're going to look at another example, still under combustion, of the combustion of sulfur dioxide gas. If we combust sulfur dioxide gas, remember the key here is that we're adding in oxygen gas. That's what's making it a combustion reaction. And in this case, we're producing sulfur trioxide gas. And then, of course, we would need to balance this reaction as well. We would need to here and 2 here. And so this actually is a good example because of this part right here of adding the oxygen, this makes it a combustion reaction. But then look at this, the fact that there's only one product here, that makes it a synthesis reaction. And so here you see that you can have reactions that have more than one type to them. They're not just limited to one of the 5. They can have multiple types, like in this case. Okay. All right, so we've got 2 out of 5. We're almost there. Let's look at some more reactions. The next one I'm going to take you through is the next type of reaction is what's called a decomposition reaction. And in this kind of reaction, this is the reverse of a synthesis reaction. And so what that means then, of course, is that you would have only one reactant, okay, that's key, that's going to make 2 or more products, right? And so if we looked at, to go down here a little bit, if we looked at the reverse of that reaction that we just did, just above, right? Look here, we had it was sulfur trioxide gas would then decompose into sulfur dioxide plus oxygen gas. And then of course you have R2 and R2. And so you see it's just one reactant giving you, in this case, just 2 products. Okay, there's lots of examples of these. Anytime you see just one reactant, that's when it's a dead giveaway. You know you're looking at a decomposition reaction. Okay, and so the last two reactions are what are called replacement reactions. Okay. Replacement reactions. Okay, so the first one we're going to look at is what's called a single replacement reaction. Okay, and in a single replacement reaction, we've kind of already started to look at these kinds of reactions in a couple of ways, just by some of the labs and things that we've been doing. But it's basically where you have a cation or an anion getting replaced by a more active cation or anion, right? And so we're going to look at this example here. We had lithium, okay, let's say, solid lithium, and it's reacting with liquid water. Okay, well, what we're looking at here really is we have lithium being positive, right? It's a cation, sorry, the board's not calibrated right, I guess. And you've got hydrogen being positive, and then oxygen being negative, right? So what you've got are this cation wants to pair up with this anion, right? And so what you're going to get then is lithium hydroxide, and you're going to get a water or hydrogen gas. And the way this worked out is because really what water boils down to, and just kind of like as a sidebar here, is this water, right, is really a hydrogen ion paired with a hydroxide ion. And so that's why you can kind of see that you've got this hydroxide that got paired up with the lithium. And then you would just balance this reaction, okay? So in this case, you'd have 2 here and 2 here, and then that would be it, and that would balance out that reaction. Oh, one more 2, rather. You'd have another 2 here in your water. But the idea is that you're just replacing one of those reactants, right? So I guess that makes sense for you, and you see how that works. And then the next one that you would want to look at is what's called a double replacement reaction. Okay. Double replacement reaction. Okay, and here is where you're going to have two sets of cations and anions being replaced. So let's kind of look at that here in this double replacement reaction. If we have sodium hydroxide, okay, reacting with copper 2 chloride, okay. And so again, if you were to look at your charges, you've got, of course, sodium being positive, and hydroxide being negative, and copper, in this case, being 2 positive, and chlorine being negative. And so what happens is this positive cation, the sodium, wants to then pair up with this negative chlorine. And then you've got this positive copper cation that wants to pair up with this negative hydroxide. And so what you really get then is sodium chloride plus copper to hydroxide. Notice we balanced out the charges first. Why did we need 2 of these hydroxides? Well, remember, each one has a negative, and each of these coppers had a 2 positive, and each chlorine here had a negative, each sodium had a positive, so you only needed 1 of each of those. And so now you can go back and you can balance out the whole reaction, which just means you're going to need 2 of these, a 2 here to balance out with the chlorine, because you have 2 over here. And then that makes you have to put a 2 over here, which then works good because your balance, your sodium balance, and then your hydroxide gets balanced with that 2 over there. And then the copper, you've got 1 of each. Okay, that's pretty much the gist of the different types of reactions. There's just one last thing I want to show you. Okay, I paused for a second to grab this screen right here. Okay, this activity series. You see here it says activity series. Not a good color choice there. Activity series. And this is just showing you this is a hierarchy. So you've got lithium here being the most active, down to gold being the least active. And the way this comes into play is when you're trying to see if a double replacement or a single replacement reaction will take place, it will only take place if it is higher up on this list. And I wouldn't ask you to memorize this. I know that's the question going on in your head. I would give you the list. Okay, yay, they're coughing. But if you had something, like if we look back at our example up here, all right, it doesn't want to scroll up. Okay. If we look here, we've got this sodium here. It is replacing the copper when it pairs with the, you see here you've got sodium, and it's essentially replacing the copper when it pairs up here with the sodium chloride. Well, the reason it does that is because you've got sodium up here, and then look way down here, there's copper. So since sodium being higher up on this list, it can replace this copper. The same reason that the other reaction before, up above here in the single replacement reaction that we looked at. All right, we had lithium replacing the hydrogen. Well, again, you've got lithium being the most active, okay, and then hydrogen is actually, it's not on this list because this is just a list of your metals, but it would be on another list that actually I could give you, and it's kind of one of those things you just know about where hydrogen's specific reactivity is. But that's the gist of the lesson. That's how you determine different types of reactions, and I hope you enjoyed this one. I'll see you in class.